We're going to look at today polynomial addition and subtraction. So when we add and subtract, our goal here is to just combine like terms, like pieces. So starting with this first problem, I have a parenthesis. Usually when we see two parentheses, we want to distribute. Not the case here because between them is that plus sign separating things. No, let's take this, add them together. Okay, let's start finding like pieces. So I like to draw shapes around my like pieces. And I'm going to look for the highest exponent first. I look for the highest exponent because I want to put my answer in standard form. Highest exponent to lowest exponent. So 2 is my highest. Let's combine them. 2 minus 4 is going to give us -2. What are we combining here? X squared. When we add and subtract polynomials, the variable stays exactly the same as we originally started with. So we start with x squareds, we end with an x squared. The next term that we have, the next highest exponent would be a 1. So we're looking at that, we're looking at that. So I'm going to draw a box around them. Now, notice when I do this, I'm trying to encompass the plus sign or the minus sign. We want to know those signs get stuck with the numbers and we don't want to lose them. If we lose them, all of a sudden the whole problem gets messed up. So make sure those signs come along with the numbers. 5 plus 6 is going to be 11. And what are we talking about this time? X's. Do I need the exponent of 1? No. And finally, we have -7 and a 3. So just subtract them. We get -4. We are in standard form, highest exponent to lowest exponent. Now there's a handful of things that maybe I want to also look for when I solve these, like what's my leading coefficient? What starts my whole problem off? Follow the leader. Is it going to be 2? Is it going to be 3? Or it's the answer, -2. So in this case, our leading coefficient is -2. It's when you put it in standard form, what's in front. What type of answer do we have? Well, here we have a trinomial, 3 groups. What's the degree? Degree is your exponent. What's the highest exponent here? 2. And we can name that trinomial with a degree of 2. We can name it by this degree 2 by calling it a quadratic. All right, what about subtraction? So subtraction, you're going to need a little bit more of a delicate eye here because this minus sign, we can't ignore it. We didn't do too much to the plus sign here. We just knew that we had to add, subtract stuff. But this minus sign is going to make a huge difference. So again, let's start drawing shapes around our terms. I want to deal with my highest exponent. So I circle highest exponent of 3. Do I have that anywhere else? No, so it doesn't combine. So when I write my standard form problem, I will put highest exponent first, and we'll move on from there. Next highest is going to be 2. Do I have any other exponents of 2's? No. This is going to be my only one. But I got to make sure I make a pit stop in the middle because I got that minus sign that's going to eventually get distributed to everything in here. So I'm just going to leave it and say minus 3x squared. Next highest, 7x and then 9x. Okay, so here's where we're really going to see us getting into this minus sign. 7 minus -9. When I have two negatives next to each other, so again, 7 minus -9. When I have two negatives next to each other, it makes a big old plus, giving us 16. 16 what's? They both have an x. That's what's coming along. And then finally, you're left with -8 and this 2, but don't forget the pit stop. -8 minus 2. -8 minus 2, giving us -10. Are we in standard form? 3, 2, 1, nothing. Yes. There's your answer. Now, couple other questions we want to ask. Leading coefficient, what starts our whole answer off? Leading coefficient's 4. What type of problem is this? Well, we have 1, 2, 3, 4 groups here. Anything with more than 3, we just call polynomial. The degree, what's your largest exponent? In this case, 3. And let's name it by degree. Anything with a degree of 3 is called cubic. And that is using addition and subtraction to simplify polynomials.